After entering in cabinets, calculating the cabinet parts, and nesting, you will need to save the toolpaths. The toolpaths are done in Part Nester. To start to save toolpaths, click or select the Toolpath tab, and you could use the thumbtack to lock the toolpath pane open. The first step in saving toolpaths is setting an order which feature is going to get machined or cut first. All of the nested DXF files have layers. We have a layer for our shelf holes, a layer for hinge holes, the side dados, the back dados, and the blind dados. We also have a layer for the cutting or the perimeter cut. The first step is to select the cutting order. In the list, we have all of our DXF layers. The cut layer is now at the top. I want to move that to the bottom. I want to cut all these parts out last. To move an item down in the list, select the layer you want to move and click the down arrow. If you have one that you just want it, you want it to be at the top or the bottom, select the layer to move, hold the shift key down, and select up. It will automatically move that item to the top of the list. The same would happen holding the shift key down and selecting down. That item will get moved to the bottom of the list. I am moving my hinge holes, shelf holes to the top of the list. I'm going to do all my drilling first. Do the back side dados, side blind dados, the bottom blind dado, the top blind dado, and cut. Once you get the order selected, close the Set Order of Layers window, and in the drop down box we'll see that we have the same layer list in our drop down box. The next step is select a layer. In this case I'm selecting the first one, hinge holes. We have to go through and select what we want to have done and what type of tooling and bit we're going to be using for this operation. In the case of hinge holes, I'm making just a direct straight down plunge. The tool diameter isn't going to matter in this case. The tool offsets is what direction the tool path is going to get offset, the outside, inside, cut on the line, or a drill. A drill operation just means that it's going to select and move the router to the center of whatever object is on that layer and drill straight down, a straight down plunge and up. The conventional incline in a drill operation has no effect. The next step is to select a post-processor that we will be using for the hinge holes. In the post-processors we have several to choose from. Select the one that is appropriate for your machine and click Save as Template. By clicking Save as Template, the next time we nest and go to Save Toolpaths and the layer hinge holes is in that nested file, we will not need to select and go through and set our toolpath operations. After clicking and saving the Save as Template, we'll go back up to the hinge holes or the drop down layer box and select the next layer in the list. Follow through and then do the same thing for each layer in the list. The backside dados, I'm going to use this. This is the dado for the backs. I'm going to cut this and select to cut this on the inside, and I'm going to be using a 3/8 bit. Our depth per pass is used to determine how many passes it will take to cut or machine our current operation. For the dados, the dado depth on most of these dados is only 3/8 of an inch deep. The tool number will be used for a tool changer. With the tool changer, the feed rate is the X and Y feed rate is how fast you will be cutting in X and Y direction. The Z is the plunge speed. We have an option here for pocket. This option is only available when the inside is selected. This would be used if we have a object, one of these layers or a dado is greater than the diameter of the bit. This will allow us to clear out and remove all of the material. For example, we have a 3/4 inch dado here. If we were using a 1/4 inch bit to cut this dado, if it went and cut around here, that would leave some material left in the center. We could then use the pocket for this option. But since I know that a 3/8 cutter will be able to make 2 passes on the dado, I don't need to use the pocket option. I'm going to leave it selected for a conventional cut. I'm going to change my post-processor. Instead of using a post-processor set up for drilling or using a drill bank, I'm going to select a standard post-processor for the router and click Save as Template, and continue the process for all the other layers. Most of them will be the same. You have to have a saved template or saved as template to be able to save toolpaths. Otherwise, when you click Save Toolpaths and try to save them, you will get a message saying that a toolpath layer is not set up. If you're unsure what layer may or may not be set up, when you click the drop down box for a layer that has a template assigned to it, in the frame for DXF layers, we will see this layer has been set up. You could use the arrow on the keypad, the up and down arrow, to scroll through the items in the drop down box. And as we look at the shelf holes and change from shelf holes to backside dado, we could see our options below have changed to match up to what we have originally selected for this layer. Once you have assigned a toolpath template for each item in the nest, click Save Toolpaths. Select the folder or the location where you want the toolpaths to be assigned. Give it a name. I had already saved this, and we could see that we have only one nested sheet, and the file names have been named as Test 1 and backside dados, bottom blind dado, hinge holes, shelf holes. This has given us one file, one cutting file for each operation. If you want all of the files or all of the sheets cutting operations to be saved to a single file or one file, in the settings there is an option to write all cutting code to one file.